Right, continuing on with our notes from yesterday. We were working through a chapter with which is called confidence intervals, and what we were trying to do is estimate a population parameter, a population mean, population standard deviation, a population proportion. And we talked about yesterday a little bit with respect to what to do with political races and the percentages that they come up with. Obviously, they're not going to pull everybody in the United States or the state of Ohio and see who they're going to vote for and actually make a prediction prior to that. But they will do a certain sample size, and they'll use that certain sample size and predict out what would happen in an entire population. As we talked about yesterday, this bottom value down here, you have the big values here that they always try to sit there and talk about, but really what you're looking at is this percent error that's down at the bottom, because you can either add or subtract 4.8% or whatever it is to be able to get the actual percentages. But that gives you a wide range of values, between almost a 10% value, whether they're going to vote for a person or not vote for a person. So really, how significant are those values at this point? But they like to try to have it as talking points. We went through some ideas yesterday in regards to properties of good estimator. You'll need to give me one of those properties. Typically, people will do the first one. Have to be unbiased. Started working through some problems that we've already done a little bit, but we have we've re-meaned the ideas of what's happening here. There's 92.1% of the cars that are between there, but we're 92% confident that we will be between two specific values, 90 and 100 months old. Talked about some terminology that will be utilized, and we went to this problem. This is where we ended up yesterday. Population average of the average or salary of teachers in Ohio is $41,000. With standard deviation of $1,500. What's the upper bound and lower bound for the salaries that encompass 90% of the salaries? And once again, this is what we talked about before and prior to, or what we did in the last chapter. And where we ended this up is we had two areas that are 0.4500. And we were able to come up with z-scores. That's the tweener one that we talked about. We're going to use a z-score of 1.65. What we want to now come down to is the actual value of these negative 1.65 and 1.65. What's our value here? And how we calculate our value was our value is equal to our mean standard deviation times our z value. So what I would like you to do is calculate these two values here. What are the two values that we would come up with? Our value is equal to mean standard deviation times our z-score. Our standard deviation is 1,500. Our mean is 41,000. And our z-scores are 1.65 and negative 1.65. What would be the two values that would be your boundary values that would encompass 90% of those values? Once again, all we're doing is basically a problem that we just did on our last quiz. Okay, these are the types of problems we did on our last quiz. Rachel, what are those two values you come up with? I'm sorry, I can't hear you. 1,000? You got 41,000. Okay, you have the negative 1.65 times 1,500, positive 1.65, 1,500. Just got to add in the 41,000. And the bottom one? So to encompass 90% of our salaries, 90% of our salaries in the state of Ohio, if given this data here, would be somewhere between 38,525 and 43,425. Those are the $2 values that you can say 90% of the teachers in the state of Ohio get paid this amount. Okay, 90% of the teachers get paid this amount. Now, if we remember back to what we talked about when we started talking about the sample or the central limit theorem, the sigma for a group of sample means, the standard deviation for a group of sample means, can be calculated by our standard deviation for the data values, our standard deviation population divided by the square root of n. That went into the central limit theorem. That was the central limit theorem. And what we're going to do is we're going to transform that equation, or this equation that we had for our value, to calculate our values, we're going to transform this into x bar. Rather than dealing with the population mean, we're going to look at the sample mean. We still have our standard deviation here, but now we have times sigma, our square root, I'm sorry, our standard deviation for our sample means, which will then transform into this value right here. So when you're talking about a sample size or a sample of size n, we can transform that into our values that we can come up with as x bar plus our z value, standard deviation divided by the square root of n. So if a sample of 40 teachers is chosen from the state of Ohio, the population of Ohio, we're just doing a sample. We're doing a sample of 40 teachers. Their mean salary was 41,000. The population standard deviation 1,500. Find a confidence interval of 90%. Well, what we are looking at up here is we have 90% of the salaries. Another way of transforming or stating what we have here is if we chose one at random. If we chose one at random, we are 90% confident the salary will be between these two values here. If you chose a teacher at random, you would be 90% confident that their population mean or their salary will be between these two values. Why? Because 90% of the salaries lie between these two values. If 90% lie between these two values, that means what we have is 90% of the salaries are there. We're 90% confident that when I choose somebody, their values or their salary will be between those two values. Once again, if you're 90% confident that when I pick somebody, I'm going to be between two values there, you feel pretty confident about that. So when you talk about boundary values, the encompassing of the boundary values of 90%, you're also talking about a confidence level of 90%. So when we start transforming our values here, we have x bar plus our z value times our standard deviation divided by the square root of n. We can start looking at the idea of a confidence level or a confidence interval. And we're going to utilize this aspect right here. I'm going to go down further before we come back to this. When you talk about a confidence interval, those confidence intervals are once again typically 90, 95, and 99%. The confidence intervals are typically in the 90% range, 95% range, or 99% range. When you talk about an alpha value is your amount of area in the two tails that we have, corresponding to a confidence interval. An alpha value is your percent not confident. Your alpha value is your percent not confident. When we talk about confidence, we have 90% of the area is between these two values. That's 90% confident because 90% of the data values are going to be between those two values. Well, if we're 90% confident, that means we're 10% not confident. If we're 10% non-confident, that means 10% of the area is not between those two values. If you're 99% confident something's going to happen, there's still a 1% chance that it's not going to happen. So you have your percent confidence, which is here, and your percent not confident, which is 1 minus your confidence interval, or if you have it in a percent, 100% minus your percent confidence. Once again, typically, you're going to be dealing with 90, 95, and 99%. This here is your population mean. Ultimately, that's what we're trying to guesstimate. We're trying to guesstimate your population mean, because it's tough for us to find a population mean because it's just too much. There's too many people. So we try to guesstimate it as best as possible. This population mean will lie somewhere between this X bar, which is your sample mean, your Z for the confidence interval, standard deviation divided by square root of n. And once again, this here is your sigma X bar, which is what we talked about up top. Now at the bottom here, we have a table. The key things to pull out of this table is you have a 90% confidence interval, 95% confidence interval, 99% confidence interval. Your Z value that corresponds to this confidence interval. Now, the most painstaking thing in regards to finding those values, those boundary values at the very end, or that we dealt with, is you had to do a bell-shaped curve. You threw in your area in the bell-shaped curve. Then you had to go to your Z table, look at your Z table, try to find the area in the Z table, and then match that up to a Z value. And that took a lot of time to be able to do that. Well, if we're always using 90, 95, or 99%, what we have done here is we have corresponded a Z value to these values here. So you no longer have to sit there and go, okay, here's my bell-shaped curve. Here's my value here. Here's my value here. I got an area here is 0.95 or 95% here. Okay, which means I will divide this by 2 and find my value here and here, and then calculate my Z value. I don't need to do that anymore. If I have a 95% confidence interval, my Z value that would correspond to 95% confidence interval is 1.96. Okay, and you can we'll utilize this table throughout your homework today and the problems that we do today. Tomorrow you'll get another table that's called a T table that will have these values on there. So you don't have to put these to memorization. You don't have to sit there, okay, I need to memorize this. No. You will have a table that will be given to you tomorrow that will have the confidence intervals on there, and you'll be able to go down to your Z value and pull these values out. Let's go up to the previous problem that we had. We want to find a 95% confidence interval. I'm taking a sample size of 40. I have a sample of 40 teachers. So my N is 40. Their mean salary is $41,000. Their standard deviation is $1,500. We want to predict out with 90% confidence the range of values for every teacher in the state of Ohio. What is their salary going to be given this data? So when we talk about the mean, once again, the mean will be somewhere between X bar minus the Z value for the confidence interval. Standard deviation divided by a square root of N. And then the exact same thing except for plus. So we could just plug in our values now. Our Z value for, we are dealing with a 90% confidence interval. 90% confidence interval, our Z value is 1.65. So now we just plug in our values and do some calculations. 41,000 minus our Z value, standard deviation, which is 1,500, divided by the square root of our sample size, 40. Then we have 41,000 plus. It just turns into a plus. And we can calculate two values. And you can type that straight into your calculator as is. 41,000 minus 1.65 times 1,500 divided by square root of 40 and hit your enter sign. And then 41,000 plus 1.65 times 1,500 divided by square root of 40 and hit your enter sign. You can type it straight into your calculator. You don't have to do pieces, parts, or anything like that. You just type it straight in. Courtney, what do you come up with our two values? Okay, so we have 40,608 and 41,395. We are not, if we take a look at the population mean of salaries as teachers in the state of Ohio, we are 90% confident we will be between these two values. That is the predicting agent that we have here. Once again, they're predicting out. This is what, once again, car insurance people do. For set your car insurance rates, they use this stuff right here. Okay? When you get speeding tickets, we are 99% confident that, okay, that speeding ticket may lead into another speeding ticket and also a car accident, which means I'm going to increase the rates of your car insurance because I'm 99% confident if you're speeding now, you get caught speeding once, there's a good chance you're going to get caught again and you may cause an accident. They take 3 years. They allow you 3 years. After 3 years with that speeding ticket there, if you have not had any type of other moving violations, they will then remove that from your car insurance. But you have to show proof of 3 years of driving safely. You also have, I don't know which one of the insurance companies that do it now, that the Safe Driver Awards, that you could have your phone, that you can log in every time you drive, and it shows you driving the speed limit. It shows it's a Safe Driver Award. And if you go into that program there, you can reduce your rates for your car insurance. Now, the one last thing that you're going to ask me do here, I'm going to ask you to do, is you're going to have to write a statement at the very end. We are 90% confident the population mean is between the 40,608 and 41,395. And if you go into a college class, and some college professors will ask you to be more specific. We're 90% confident the population mean of the salaries of teachers in the state of Ohio. Population mean of the salaries in the state of Ohio for teachers is between this value and this value. But I will ask you to write a statement at the very end. I'm okay with 90% confidence the population mean is between this value and this value. I'm okay with that. Once again, you're going to be asked to do problems here. Just look at this, look at your notes and find your Z values for those values that you need. Maximum error. Your maximum error is the difference between the population mean, mu, and the maximum distance to the confidence interval. Your maximum error. the maximum error. How we calculate, once again, confidence interval is your x bar plus or minus a z for the confidence interval, standard deviation divided by square root of n. This quantity right here is your maximum error. So this error that you have is this right here. Here's your sample mean. I'm adding and subtracting a value. I'm adding and subtracting a value. That value is the error that we have. It's the value that's being added or subtracted to your sample mean. If the population standard deviation is not known, that's fine. Use your sample. Alpha divided by 2 just means your confidence interval. Some books will just use the alpha divided by 2. It means your confidence interval. You just use your sample. If you don't know your sigma, you use S, and that's okay. Statisticians are fine with that. Why? Because they just want a number. They want a number. And the sample can give you a guesstimate on the population with respect to the sample standard deviation. So you just replace that with sigma. It's the exact same thing we did on the other side. If you want to be more confident the population mean lies in an interval, you're willing to trade off a bigger confidence interval. The bigger the confidence interval, the bigger the range of values. If I'm only 90% confident, I shrink my interval down. If I'm 99% confident, that means I'm going to widen that out a little bit. Because I'm saying I'm 99% confident, I want to make sure I'm going to get my value in there. I'm going to widen that thing out. So basically the larger the confidence interval, or bigger the confidence interval, the larger the range of values. So the bigger the confidence interval, my range is going to be a little bit bigger. To be able to find a confidence interval, the sample size must be large enough. We use 30 as a barometer. Once again, law of large numbers says the more you can have, the better off. But usually 30 is a cutoff. You want to get things greater than 30. As statisticians, sometimes they'll sit there and go, we can live with a specific error. We can live with a specific error. Well, to get this specific error, what does our sample size have to be? If I'm okay to live with this amount of error, what does my sample size have to be? So they go back, they backtrack it basically. So you have this error is equal to z for the confidence interval, standard deviation, square root of n. If you solve for n here, We can multiply both sides by square root of n, and divide by this error. So you can solve for this n by squaring both sides, and this is what you end up with. This will give you an error, a minimum sample size for the maximum error. If I'm willing to live with an error of 20 cents for something, and that's my error, I can plug it in there and say, I need to have a sample size of at least 90 people to be able to get that sample size or that error of 0.2. A square term. This right here. This is just that right there. Common mistake is forgetting the square term. And once again, you want to, if you get 37.3 people, okay? You get 37.3 people. We'll round that up to 38. Go through one last problem here. Survey of individuals who passed all 7 exams to obtain the rank of a fellow in the actuary field find an average salary to be $150,000. You want to make, if once again, you don't want to be an accountant because you don't like debits and credits. Okay, you don't want to deal with that. You don't want to become an engineer because you don't like the sciences. Okay, I'm not very good in physics, so I don't like that. But you like math, something you really, really enjoy. You enjoy the math world. You just don't want to deal with debits, credits, and all that stuff. And you just want to work with numbers. Okay, there is called an actuary field or an applied math field. It's one of those fields where when I was you guys, yes, and that was a long time ago, but when I was you guys sitting there and had no clue what I wanted to do, no clue what I wanted to do after high school. I was living in the moment, just like you guys live in the moment. And they started saying, well, what are you going to do in college? I don't know. Well, you're good in math and you're pretty good in science. You should go become an engineer. Oh, all right, if that's what you say I should do, I guess I'll do that. So I went to the University of Akron and got an engineering degree. But as I went through that aspect of it, I was so close to the end, I started to realize that engineering was not me. And that's what took me back into the math world and the education world, and I became what I am. I've enjoyed the 35 years of doing it, I really have. But if this would have been put to me 35 years ago or 40 years ago when I was your age in school 40 years ago, probably would not be standing here in front of you right now as a teacher. Because the actuary fields and working with math and statistics, I enjoy this aspect of teaching with respect to statistics and dealing with the mathematics of it. I would be doing that. Not that like I said, I've enjoyed my 35 years of doing what I do, really have. But if you're interested in something that you want to do after in college and you really like mathematics and you really enjoy it, right there, nice little field. You got Buku Bucks right there. Okay, Buku Bucks is working at. This is $150,000 a year. Okay, I was at a seminar, oh gosh, this was about 15 years ago, University of Findlay. Teacher was up there, or a professor that oversaw us was talking about one of her students was he graduated with an applied math degree, which is next to your actuary fields. You go into applied mathematics. Basically, you have an option to become an actuary. that works for insurance companies, stockbrokers, all those people. Every company has these because every company needs people that are going to forecast whether they're going to make profits or have losses. Every company has these people. Okay, Smucker's has these people. Why did Smucker buy coffee and dog food? Okay, why did Purina and whatever the coffee was, Procter & Gamble, they bought all these different things. Why? Because their actuary people said you can make a profit off of this. You can make a profit off of this. You should buy that. So they bought them. Okay, but going back to the University of Findlay, the person said she had an applied math student, was graduating, didn't have a job lined up. A day or two before graduation, the government called this person up, and interviewed the person on the phone. And that was the sole interview. That was 2 days prior to graduation. The day before or the day of graduation, the government called him up again and says, we will offer you a job at $90,000 a year. You have to move to Washington, D.C. We got a job for you at $90,000 a year. One phone interview, applied math. Okay, so there's money that is sitting there if you want a job that you like mathematics, you want to do stuff like this. We're going to take a look at, let's change this to 99. We haven't done the 99%. Actuary field, the average salary, $150,000. Standard deviation, $15,000. We have a sample size of 35. We want a 99% confidence interval. So we have to look at Z for 99%. So we look at the previous page, Z for 90%, 99%, 2.58. Previous page, 2.58. So we want to find what we're going to be in between with the population mean. So we have $150,000 minus our Z value. Standard deviation of 15,000 divided by the square root of 35. And then we do the exact same thing and we do the plus on the other side. And we come up with our two values. A lot of repetition in regards to what you're doing here. It does not vary too much in regards to the problems that you're dealing with. This procedure that we just did there, you write your three values down. What's a confidence interval? You look at your table for your Z value. And you write yourself two equations there. One a plus and one a minus. And click to the calculator. Then once again, write your statement at the very end. I'm 99% confident that I'm going to be in between, my population mean is going to be in between this value and this value. Okay? And it's, once again, it's repetitive as we go along. Part A and all your problems. Part A and all your problems for your homework. I ask you, what is the best point estimate? Our best point estimate. Yesterday, what did we talk about? What's our best point estimate? Best point estimate's the what? And what's the best one? That's exactly correct. What's the sample mean? So your best point estimate is, I give you a sample mean here, that's your best point estimate. All right, tomorrow we'll talk about T-tables. We do the exact same stuff all over it again, but we use a T-table, different chart, and we move forward. Unfortunately, we'll get a quiz before the end of the or before spring break. When we come back from spring break, we're going to have to do unit tests over this material in the last chapter. Just not enough days. Not enough days. Questions? Solutions have been posted for you. Adios. Have a good day.